Hello Cloud Gurus and welcome to this lesson during which I'll be talking about the initial data model for the Learning Online case study. And from this point onwards I'm going to refer to this data model as version 1 of the data model. And we will be refining the model throughout this course, so there will be several more versions. By now, you should start to understand the structure of data within DynamoDB, and by watching the lessons in the introduction section, you should understand the basic concepts of data modeling used within traditional SQL databases. In this lesson, I'm going to step you through the initial model for the Learning Online case study. And as this is the case study that I'll be using throughout most of the demo sections of the course, it will be the one that you need to fully understand. I'll spend time explaining why I've chosen the structure that I have, and I'll discuss any points which have multiple possible solutions. By the end of this lesson, my hope is that you have a foundational understanding of how to design a data model for a production scale system. The first step in planning a data model is understanding the data that you have to manage. I spoke briefly about this in the data normalization lesson, but the principles apply even with NoSQL data models. I always like starting by asking myself a few questions, and you may recognize some of these from the database fundamentals section. Understanding your data should be a common theme across all the systems that you design and manage. You cannot design a model which delivers the performance you need and expect without understanding it fully. Firstly, what groups of data exist in the system? I'll talk about this more in an upcoming slide, but for the Learning Online example, which is an online school, you should already see that there will be students and teachers, and with that realization you have identified two data groups. Now there will be more, so start thinking about the others. Next, understand when the data will be accessed. Will it be linear over a day, a week, or a month? All databases preference uniform access from a time perspective. If you have non-uniform access, i.e. peak periods, then that suggests caching or some other measure to mitigate the burstiness. Be aware of this from the offset. Next, think about the data access patterns. This may well relate to the time question above, but think about more from a business process element. Consider a student sign-up. What tables and other data will be accessed when a sign-up occurs? Then consider data growth. You will have identified your data groups above. For each of those, consider and plan for how that data will grow. There are implications to growing datasets in all database types, and especially DynamoDB, which handles scaling in a very specific way, and you'll learn more about this later in the course. When thinking about data growth, split your data into immediately recorded data, recent data, semi-recent, and older archive-style data. Will accesses on that data be uniform? Will older data be accessed less or more, as may be the case for historical reporting? Data with differing access demands based on age needs to be handled in a very specific way, or at least needs careful consideration if the volumes are high enough. Understand the end-to-end query layout of a system in advance. This starts with what business processes need what data, but it goes deeper into what those business processes actually do. Formally plan the flow of data and the modification of data before you write a single line of code or create a database table. When designing the data model, consider if any alternative perspectives are needed. The system might record details of students based on student ID as the key, but what if a list of students based on location is needed? Know this in advance. When I talk to you about indexes and when I demonstrate indexes, it will become immediately apparent why this is important from the outset. Next, look if the system will have any batch processes. Will data be looked at in bulk at certain times for certain data groups? What will these be? How intensive will they be? When will they occur? How regularly? And how long will the process take? These are all good questions to ask yourself for all aspects of the system. And conversely, will the system have any real-time requirements? Will there be any events that occur in real time or almost real time? Events that require immediate action. Conceptualize and plan for as many of these in advance as you can, as it will help you when designing the data model. Okay, so with those questions in the forefront of your mind, let's step through the Learning Online example together. It's worth at this point reminding ourselves of the key elements of the Learning Online case study. Learning Online is an education provider which provides professional and K-12 education services to students around the world in 80 countries, 20,000 staff, and over 100 million students worldwide. They have 25,000 courses available, which consist of many modules, and the school has 100,000 exams running daily, averaged over the year, with some peak periods. At a high level, the system manages students, teachers, exams, attendance of lectures, both online and remote, courses, facility bookings, and more. Keep all of those high-level facts in mind in this lesson and throughout the course. So let's talk about the specifics of the data model. The first thing I want to consider is the groupings of data within the system. Many times, building a system just around the logical groupings is enough. Performance requirements are low enough that you don't need to tweak it from a performance perspective. Adjustments may be required over time, and that's something that together we'll evolve during this course. I mentioned this before a few slides ago, but one of the first and most obvious base data structures our system will have is that of a student. Students will form the core of Learning Online, and with over 100 million of them, will form one of the largest groupings of data within our system. Now, for students, we'll be storing a few groups of data. We'll have the name, date of birth, sex, address, a government ID number, and a scan of that ID. And I'm proposing that we keep all student-specific information in a table, as it's likely that that information will be accessed at similar times for similar operations. The first decision that we need to make when we're modelling data is how we group the data together. And it's logical, in absence of any other information, to group data together based on usage and type. So that's why I've made the decision to store, at least initially, all of the student data together in a table. Now, likewise, we'll have teachers, and the information we store for teachers will be almost identical to that for students. So, for example, name, date of birth, sex, address, and government ID, amongst other things. Now, a great question you might, I hope, be asking yourself at this point is why two tables? Why do we not store teachers and students together in the same table? As the course progresses, the technical reasons for this will become clear. But for now, just realise that the access patterns and demands on the two sets of data may be substantially different. Our system revolves primarily around students, with teachers being a supporting structure. Their records potentially will be accessed much less than student records. So by having them in one table, we can't performance split across those two groups. If we have a student table and a teacher table, we can specify performance on each of the data groups, and that might be a more cost-effective way to manage performance within our system. With DynamoDB, there is no penalty to having many smaller tables, and it actually gives you certain advantages, the performance allocation being one of them. You will also learn that certain things like indexes are defined on a per table basis. So as a base point of reference, you're always better erring on the side of having more smaller tables for discrete data access use cases. So for now, I'm going to split teachers and students into separate tables. We can easily merge these together at a later point. So next, we have another core data type within the system, and that's a course. The system will store 25,000 of them in total. And for courses that the system stores, we also have details such as name, description, pass mark, and the modules which the course is made up from. Now, for each instance of a course running in a given year, we need to store the course instance. And for the course instance, we might be storing the year that that course operates on, the capacity of that particular instance, the students allocated to that particular instance of the course, and then the modules that that specific course instance is made up of. Now, my logic here is that you may have a specific instance of a course, for example, an AWS certification course, where for a given year, you might have slightly different modules. For example, if the vendor has updated the syllabus with extra requirements. And so whilst the course record has a list of base modules, you might want to allow customization on a course instance basis. You may also be asking yourself why we're having course instances and courses in separate tables. And again, this is due to what I think the access requirements on those tables will be. I'm imagining that courses will be more of a reference table where you're occasionally viewing the contents when you're picking a course or when you're generating a list of courses for the website. Course instances might be used from a more operational perspective by both students, teachers, and admin staff. So it makes sense again to separate that just in case we need to allocate significantly different performance criteria to that table or create different indexes or representations of the data specifically for the course instances. So again, while the design wouldn't be wrong to combine them, I think there is logic in separating them. Now, the system will also store bookings, and these can be bookings at physical locations for lectures or exams, or purely time bookings for online lectures or webcasts. For a booking, it makes sense to store the module to which it applies, the location, a start date and time and an end date and time, and the booking type, whether it's an exam or lecture. And finally, for a physical location, you'll also want to store the capacity of the venue. Next, we have modules. And modules are the building blocks of courses. A course can have one or many modules. A module is a discrete teaching unit in a specific language, i.e., Algebra Basic English. For the module, we'll likely want to record the description of the module, a pass mark, and a teacher who is the primary teacher for that module. So obviously our system will need to track the attendance and completion of exams for students, and so we will have an exams table. For exams, there is a wealth of data which needs to be stored. There is obvious data such as the exam ID, which is a unique identifier for one student attending one specific exam. We also want to store the course instance the exam is for, the module which the exam is for, and any bookings which the exam is linked to. We also want the location of the student sitting the exam. We want to be able to store the grade that they achieve, together with any comments. And finally, security information such as entry and exit scans. And this might be a facial ID scan, a digital copy of the exam paper, and potentially any extra information suggesting if the exam result is questionable or voided. And lastly, we have attendance. And attendance tracks when a student physically or virtually scans or logs in to a lesson booking. And note that scanning into a building is different than actually starting an exam, so different date and times can be recorded. So for attendance, we might want to store the booking ID, a student ID, the location that attendance is for, and then the date and time entered and exited for that attendance. Now, my hope is that even at this stage where you haven't got a lot of DynamoDB or data modeling experience, you can look at the groupings of data on screen now and understand the logic in how they're structured and separated. If you do have anything radically different or any questions or concerns, I would love to hear from you. So maybe start a discussion on the forums and we can talk further. I always like to talk to students around the decisions I've made when designing a course. If you do have any improvements, I would love to hear them, and maybe together we can make the course better for future students. Thanks for listening, Cloud Gurus, and this is the end of part 1 of the Data Model version 1 design lesson. If you have any questions, feel free to reach out either directly or via the Cloud Guru forums. Otherwise, feel free to complete this lesson, and I would recommend immediately watching and listening to part 2.